Okay, object-oriented programming using Java. So today we will deal with object-oriented programming using Java, and the module deals with approach to software design, function-oriented design, object-oriented design, and case study of automated fire alarm systems. Before moving on to the topics, first we will see what is software. A software is just a collection of instructions that enable the user to interact with a computer. Without a software, the computers would not be useful. For example, without internet or software, we cannot surf the internet. And without an operating system, we cannot run a computer too. So we will divide our softwares into two types. First one is system software and second one is application software. And some of the examples that are related to system software are operating system, compilers and interpreters. So we will see what the system software is. System software is a software designed to provide a platform for other softwares. So it's a platform that is related for other softwares to run. And some of the examples are operating system, compilers, interpreters, etc. Then next, application software. Application software includes some of the examples related to application software like Microsoft Word, MS Paint, Microsoft PowerPoint, etc. So from this example, we can say what's an application software. Application software means it's a software that means it's a set of instruction that is used for specific tasks or specific applications. So application software is a software that is used for some specific applications. Then next we will see software design. You know that software design deals with a software requirement specification document. That is, we will convert some of the requirements needed for our customers into an SRS format. And that's a software design. The design document is provided by the customer, and then the customer is design the software and transfer into SRS documents into a design document. And design document implemented using a programming language. And the first step of this software design is software design lifecycle. Next, we will see some of the approaches related to software design. There are two approaches for a software design. First one is function-oriented design and the second one is object-oriented design. Then function-oriented design. From the name itself we can say it's related to some functions. That is, a system is composed of many smaller subsystems known as functions. Here, all the tasks related to our systems are performed using some functions. And each function is successfully defined into more detailed functions too. Then, some of the features related to function-oriented design. That the first one is top-down decomposition, and the second one is centralized system state. What do you mean by that? Top-down decomposition? That means we will having a root node, and from the root node it will be decomposed into smaller leaf nodes. That is top-down decomposition. Okay. A system at starting level is viewed as a black box that provides certain service, also known as high-level function, to the user of the system. This function will be refined into some subfunctions, and each of the subfunctions may be split into more detailed subfunctions and so on. That is, we will have a small or a function with all functionalities for a system. And the second stage, it will divide these functionalities into some sub-functions. And then these sub-functions are then divided into smaller functions. That is top-down decomposition. Then for example, for a top-down decomposition is a library management system. You know that in a library management system we have some functions. One of these functions are create a new library member, issuing book, returning book. All this comes under this top-down design. Function create new library member, assign membership members. Okay, for creating a new library function, it is then we can divide the functions into sub-functions such as assign membership member, then create member record, then print box. And also for next we will consider issue. issue book is also a function, and if this issue book can be then subdivided into some functions like how to issue a book. For issuing a book, we need the library number, then the book name, then book ID, then return date, then issue date. So the issue book is also subdivided into some functions using these functions. Then for returning the book also we have another function. For returning the book, we need to check whether the date return is correct or not, or if the date is not correct, then we want to pay some payment, or we want to pay some fine for that. So we can divide that fine into next subfunctions. So this is a top-down design. Then it's a centralized system state. A system state is centralized and shared among different functions. For example, data such as member record is available for updation to several functions such as create new member, delete member, update member record, etc. Then next we will see object-oriented design. The system is used as a collection of objects, and state is decentralized among the objects. Each object manages its own state information. An object is associated with a set of functions. A set of functions is called methods. Each object contains its own data and is responsible for managing it. The data internal to an object cannot be accessed directly by other objects. In a function-oriented design, it gives more emphasis on a function, and in an object-oriented design, it gives more emphasis on data or objects. Then object-oriented design, here we see some example, and each library member may be a separate object with its own data and function to operate on these data. The principle behind this object-oriented design is abstraction and decomposition. Then what's a decomposition? It's just an object is decomposed in a system into functional independent modes. And a data abstraction means we are hiding the data from all knowledge. Implies that how data is exactly stored in an abstracted way. This means that any entity outside object will not have the knowledge of it. That means we will hide our object's data. How data is exactly stored, organized, and manipulated inside the objects. Then an example employee payroll software, and how we can differentiate between FOD or functional-oriented design and object-oriented design. For a functional-oriented design, you know the design functions such as update employee record, get employee record, etc. deals with functional-oriented design. And in an object-oriented design, it deals with designing objects such as employees, department, etc. And in a banking process, we know the function-oriented design functions are withdraw, deposit, transfer, etc. And in the object-oriented designs are designing objects such as customer, money, account, etc. Okay, then the next slide deals with what are the difference between functional-oriented design and object-oriented design. The first step is, or first main point is, the functional-oriented design it gives more emphasis on services, and in object-oriented design it gives more emphasis on real-world entities. And the state information is centralized and shared. Here in object-oriented it is distributed. Then the group functions can be divided from top-down approaches in functional-oriented design, and in object-oriented design it is in bottom-up approaches. And decompose the functions. In functional-oriented design, it decomposes the functions into functions or procedure levels, and in object-oriented, it will decompose it into a class levels. Then this group of functions are set together on functional-oriented design, and in object-oriented design, group functions together on the basis of the data they operate on. Then we will see an example related to case study of a fire alarm system. A fire alarm system means we have a fire alarm system, and whenever the home is inside detects some smokes or fires, then it will detect the fire alarm system. And whenever a fire condition is reported by some of the smoke detectors, the fire alarm system should determine the location at which the fire has been sensed, and then sounds alarms only in a neighboring location. The fire alarm system should also flash an alarm message on the computer console. After a fire condition has been successfully handled, the fire alarm system should support resetting the alarms by the by finding post-header. So, uh, in function-oriented design approach, what will be considered as functions, or what are the functions that relate to functional objects? For a case studied automated fire alarm systems are get detector location, determine neighbor alarm, determine neighbor sprinkler, ring alarm, activate sprinkler, reset alarm, reset sprinkler, and report fire locations. And for an object-oriented design, we will classify it into a class of objects. Some of the class of detectors, attribute, class detector, then class alarms, class sprinkler. In the class detector, it will be having attributes and operations. Some of the attributes relate to class detector are status, location, neighbors. And operations related to class detectors are create, send status, get location, find marks. And for a class alarm, attributes are location and stats. And the operations related to that are create, ring alarm, get location, reset alarm. For a class sprinkler, the attributes are location and status, but operations are create, activate sprinkler, like location, reset, sprinkler. Okay, thank you.